Welcome to Piece of Math. Let's talk about how to factor polynomials. This topic will be split up into 3 videos, factoring polynomials with 2 terms, 3 terms, and 4 terms. In this video, I'll walk you through step by step on how to factor polynomials with 3 terms with some extra practice problems for you to try at the end if you need. When you have 3 terms, you can use the same techniques for factoring quadratic expressions. There are several different methods you can choose from, but my favorite is the bottoms-up method. Let's start with a basic review of factoring quadratics. When factoring quadratic expressions like this one, first we would look and see if our leading coefficient is 1. So if this is 1, then we can just find numbers that will multiply to the last number that add to the middle. So for example, you could do 1 times 14, 2 times 7. These are all the ways that multiply to 14. And if I want the pair that adds up to the middle number 9, this would be my pair of numbers. So then we would factor this as x plus 2 times x plus 7. And then notice we're splitting up the x squared. Each one gets one of the x's. So if I was changing this to a polynomial, let's say we had this, we would factor this in the same way. Leading coefficient is 1, so we'd look for numbers that multiply to last that add up to the middle, so that would be 2 and 7, and we can start to set up our factors again, except instead of it being x plus 2, this time I have x to the 4th, so when I split up into my 2 parentheses, each one is going to get 2. So it's going to be x squared plus 2, and then x squared plus 7. So that way when I multiply these, x squared times x squared, add the exponents, and that would give you 4. So this is how you would factor that polynomial expression. Very similar to how we factor the quadratic. Okay, so what do we do if this leading coefficient is not 1? So here's this method called bottoms up. So we're going to multiply first times last, 5 times negative 8. This gives you negative 40. And then we're going to look for numbers that multiply to this number that would add up to the middle. So for example, we could do positive 10 times negative 4. These multiply to negative 40, and if I add them up, I get the middle number 6. And we're going to start to set up our parentheses. And we're using x squared, remember, because we're splitting up x to the 4th. So I'm going to start to set this up, x squared plus 10 times x squared minus 4. And if I stopped right here, if I multiplied this out, I've got x squared times x squared, which will give me x to the 4th, but it's supposed to be 5x to the 4th. So here's where this bottoms up method comes in. Since I multiplied this last number by the 5, I have to undo that step. So I'm going to divide both of my numbers by 5. So divide this by 5 and divide this by 5. Here, 5 goes into 10 evenly 2 times, so we're going to simplify this. 10 divided by 5 gives you 2, so this is x squared plus 2. Here, 5 doesn't go evenly into 4, so I can't reduce this fraction, so now I'm going to move the bottom number up. So bottom number becomes my coefficient of that variable, so it's 5x squared minus 4. And this would be our answer. Let's take a look at one more where we don't have a leading coefficient of 1. I want to take a look at this one because there's going to be an extra step at the end that we didn't have to worry about with the other ones. So if I try to factor this, we're still going to multiply first times last. 3 times 4 gives us 12. And then numbers that multiply to this that would add up to the middle, that'd be negative 1 and negative 12. And if I start to set up my factors, we do x squared minus 1 and then x squared minus 12. And then if I do the bottoms up part, so since I multiplied this 4 by the first number, we're going to divide by the first number 3. So dividing both of these by 3. Here, 3 can't go evenly into 1, so bottoms up. This becomes 3x squared minus 1. And here, 3 goes into 12 4 times, so we get x squared minus 4. Now with this problem, we'll be able to factor it further. Because if we look at this expression in this parentheses, this x squared minus 4, this one we can factor further. And you can think of this as like x squared plus 0x minus 4. So if I was factoring this, my leading coefficient is 1, so numbers that multiply to last add up to the middle, that'd be positive 2 and negative 2. So this part we're going to factor to x plus 2 times x minus 2. And a little hint on whether or not you'll be able to factor it further, look for the difference of 2 squares. So here I have the difference, minus sign, and then I have 2 perfect squares here. 4 is a perfect square, I can find the square root, and same thing here, this 1x squared, we can find the square root of 1, which is just 1. So that's the most common time where you'll be able to factor it further, is if you have this difference of squares. So for our final answer, I'm going to bring this first one down, 3x squared minus 1, and then for the second part, this x squared minus 4, I'm going to change that to this x plus 2 times x minus 2. So this time we have 3 parentheses in our answer. And just a quick double check, if I multiply out the x's, I've got 3x to the second times x to the first times x to the first. If I added up the exponents on the x, that would give me x to the 4th. So just a quick little double check. But you can always multiply all of this out and see if you get to the original expression as well. Here are some extra problems if you need a little more practice. Pause the video and try these out on a scrap piece of paper. Good luck! Here's a list of the answers to the practice problems. Remember, if you're not sure if you got the answer correct, you can always multiply out the parentheses that you ended up with and see if you get back to the original expression that was in the problem. Need to factor a polynomial that doesn't have 3 terms? I have a video on ones with 2 terms, and there'll be one on 4 terms soon. Thank you for watching, and I hope this video helped you find a little peace in math.